Hello, welcome to probability relative frequency video. In this video, you have two objectives. The first one is to learn how to compute relative frequency, and the second one is to use relative frequency to predict or estimate values. Okay, let's begin the explanation by finding out what is relative frequency. Okay, it is an estimate of the probability of an event happening that can be obtained by looking at your experiment or statistical data. Okay, so let's have an example, and then also here you will see how to get the relative frequency. You can get the relative frequency by dividing the number of times that the event occurs over number of trials. Okay, and I'm going to show you how to do that. Okay, so we have an experiment, and this is a survey or by observation. You gather data by observation. In the experiment, you're going to use a die or one die, and you're going to throw it and then find out what's the probability of each event occurring. When I say event, you will have 6 different events. That will be 1, 2, 3, 4, 5, and 6. Okay, now this die though is biased. This is an unfair die. Okay, so the result is not going to be fair. Okay, so based upon the experiment, when they throw the die, they counted everything. Okay, out of 250 trials, they throw the die 250 times. The one came out 25 times, 2 came out 34 times, 3 32, and then so on and so forth, 6 95 times. As you can see here, the die is favoring 6 because the 6 appeared so many times. If you are using a theoretical probability, you will argue that they should get almost the same number of times because they should have a fair chance. Each event should get a fair chance. So that's why you know this die is an unfair die. Okay, now to get the relative frequency, which is our lesson for today, what you do based upon what you have here on top, number of times that the event occurs divided by number of trials, you go 25 divided by 250. So the probability or the relative frequency of 1 is 0.1 or 10%. Okay, so we do the same for everything. So 2 came out 34 times divided by the number of times you did the experiment, which is 250, the total. So for 2, it has 13.6%. The relative frequency or the probability based upon this experiment is 13.6%. We're going to do that for all 6 events. Okay, so, and the last one, as you can see, 6 came out, it has 38% probability. Okay, now let's go to data survey or by observation. We are looking at the colors of the cars passing through traffic lights. Now, it's just like a person or people standing and then counting the number of cars depending upon its color. So out of 350 cars that went through the traffic light, 50 are red, 80 blue, green 30, so on and so forth, black is 20. This is a fair observation or survey. Okay, so then to get the relative frequency, you divide the number of red cars divided by 350, the total number of cars that you have seen. Same thing with blue, 80 divided by 350, and then you do the same thing for everything. Yeah, so it seems that based upon this survey or the the most popular color for the car is silver because silver has 37%. Okay, now let's keep going. How do we solve problems? There are problems that could be presented like this one. You can see these two, one experiment and then the survey. Okay, so the probability of the next row being a 6 is approximately 38%. Okay, so we are interpreting this. The probability of the next row of being 1 is approximately only 10%. Okay, now on the other hand, the probability that the next car being blue is 23%. This is based upon what they have observed at a certain period of time. Okay? And then the probability of the next car being silver is approximately 37%. Okay, so this is how we interpret your data. Now, let's have some few questions. Relative frequency can be used to estimate the number of times that an event is likely to occur within a given number of trials. So, for example, when you are using this table to estimate the frequency of each number on the die for 1,800 throws, using the same die, a biased die or an unfair die, okay, and you're going to throw that die 1,800. The probability, you don't have to throw 1,800. Using your experiment, the result of your experiment, you can draw or predict the number of times each event will occur based upon your data. So, how do you know that upon 1,800 throws, 1 will appear 180 times? Because 1 has a probability of 10% or 0.1. So 0.1 multiplied 1,800 is equal to 180. Okay. For number 2, what are the chances, like in 1,800 throws, how many times will it appear? Based upon this observation or data, statistical data, you can predict or estimate the value. You don't have to throw it 1,800 times. 2 will come out probably 245 times. Okay? You use the relative frequency times the number of throws. The same thing for everything. And guess how many times will 6 appear? 6 will appear 684. Way higher than the others. Because you know, this die is an unfair die. It's a biased die. Okay. The next one that will appear the most is 5. Okay. So, this is how you use relative frequency or the probability of relative frequency when you have statistical data. Okay, now let's use the observation or the data survey for the car, the color of the car. Now, you do not have to stand all day after observing 350 cars passing by. You can make an assumption or a calculated guess. When you have 2,000 cars, how many do you think will be red? Using your data, statistical data and information, you know that the relative frequency is 0.14 or 14%. You can use that to find out how many red cars will be passing by if there are 2,000 cars. You just multiply 0.14 by 2,000 and you will know that there will possibly 280 red cars will pass by in 2,000 cars. Okay, so the same thing with the other colors. Blue, 23% of 2,000 is 460. Green, 180 green cars will pass by out of 2,000 cars. White, 220. Silver, 740. And black is 120. Based upon this survey, silver is the most popular color and black is the least liked color of the car. Okay, so this is what it means. Okay, let's have the last example. A bag contains an unknown number of colored discs. Rebecca selects a disc at random from the bag, notes its color, then replaces it. So she puts back. Whenever she gets a disc, she puts it back inside. She did this 500 times and she recorded the result on the table. Rebecca hands the bag to Peter, who is going to select one disc from the bag. Use the information from the table to find the estimates for. You have the following questions. But here is the result of Rebecca's experiment. She got the blue disc 8 times out of 500, and then 85 for green, 200 for red, yellow 115, white 92. Remember that we don't know the number of discs inside the bag. This is just what we know. Okay, so then when it's Peter's turn, you can estimate how many Peter will get. What's the probability that Peter will select the red disc? You will base it upon the experiment that Rebecca did. So how do we do it? Okay, we will find the relative frequency of red. Okay, so 200, if you add the number of trials, it's 500 times. So 200 out of 500, that's 2/5 or 0.4, which is 40%. So the probability that Peter will select a red disc is 40%. Okay, and then on B, the probability that he selects a blue disc. So it's the same. Get the relative frequency, which is the probability. Okay, it's an experimental probability. P blue is equal to 8 out of 500. So getting blue is very difficult. Yeah, it only has 1.6% probability. Okay, there might be just one blue disc there and a lot of red discs. Okay, remember, we don't know the number of discs inside the bag. Okay, that letter C, the number of yellow discs that Rebecca could expect for 1,800 trials. So if she's going to keep on getting disc from the bag and then returning it, okay, how many times will she get yellow? First, you get the relative frequency of yellow, which is 115 divided by 500, the total number of times that she took a disc from the bag. Okay, it's 0.23 or 23%. So 0.23 times 1,800. So she will probably select the yellow disc 414 times out of 1,800 trials. Okay, so grade 10, I hope that you understood this lesson about relative frequency. There will be an independent practice that goes with this lesson. So answer them, and if you can't, you can watch this video again. Okay, bye. I'm sorry that I cannot be with you there today. Okay, bye.